Hi there. Hi there. Today we will discuss singleton design pattern and various subtopics like what is singleton design pattern, when to choose singleton design pattern, code demonstration, interview questions and answer, and finally a quiz on it. So first let's understand what is singleton design pattern. The singleton pattern is creational pattern that ensures a class has only one instance and provides a global point of access to that instance. In essence, it restricts the initiation of a class to a single object. Let's understand when we choose singleton pattern. When there must be exactly one instance of a class. This is typically useful for resources such as database connection, thread pools, logging systems, and caches where multiple instances would be wasteful or problematic when access to a single shared resource is required. The single pattern ensures that all requests for the instance return the same instance, allowing for centralized control of the resource. When lazy initialization is desirable, if the creation of instance is costly in terms of resources and is not always needed, the singleton pattern can delay the creation until the instance is first requested. To understand this better, let's jump into the code. This is a simple example of singleton class. Singleton instance is static, which makes sure only one instance is created. Also, we can see the constructor of the class is private, so it cannot be instantiated from outside the class. Now, we also need a way to access this instance. For that, we have created getInstance method, which is used to provide access to a single instance of that class. If the instance does not exist, it creates one. Otherwise, it returns the existing instance. This method is static so that we can create them without creating instance of the class. Also, we will see the behavior of class that is non-singleton. So this is our class which is non-singleton and it just returns the instance of its class. To understand the difference, we have used hashcode comparison where we can observe that if hashcode for two instances are same, which shows that they are same instance, and also we are using equal to, which shows that both the instance point to exactly same object in the memory. Let's try to run and understand. Here we can see for non-singleton, the instances are different, and for singleton, hashcode are same and therefore these instances are same. There are two more approaches which can be used based on requirement: lazy initialization and eager initialization. Lazy initialization is here that we saw. It says that it involves creation of the single instance only when it is first requested. This approach delays the instantiation of singleton object until the first time it is needed. Second is eager instantiation, which is this one. Eager instantiation creates the singleton instance at the time of class loading, regardless of whether it is immediately needed or not. This approach ensures that singleton always is available but may consume unnecessary resources if it is not used. Let's see demo of this as well. Here also we can see, in case of eager instantiation, we are able to observe that the hash code are same. Another way is by enum. A typical situation is there when two threads are using the same application. Both threads can execute a single code and create two objects. This means that this application is not thread safe. Simplest way to resolve this issue is to make class synchronized, but that can degrade application performance if this method is called multiple times. Solution to this issue is enum, as enum gives guarantee of thread safety. Here we just have one static instance and we return the same in getInstance method. Let's see how this works. Here also we are observing that the hash codes are same. Disadvantage with this approach is that we will not be able to extend a superclass of singleton, as an enum cannot directly extend a superclass because Java enums explicitly extend the java.enum.class, which is a final class. Therefore, enums are Java implicitly final and cannot have subclasses. But otherwise, this is the best approach to implement singleton design pattern. Based on our understanding, let's see what questions can be asked in interviews. Always remember, the key to acing an interview is understanding the concept thoroughly and being able to explain your reasons clearly. The first question that can be asked is what is singleton pattern and how does it works? The singleton pattern is a creational pattern that ensures a class has only one instance and provides a global point of access to that instance. It typically involves a private constructor to prevent external instantiation and a static method to return a single instance, creating if it is necessary. Second question is, explain the different ways to implement singleton pattern in Java. The singleton pattern can be implemented in various ways in Java, including lazy initialization, eager initialization, using enums, or by using statics. Lazy initialization involves creating the instance only when it is first required, while eager initialization creates the instance at the time of class loading. Enum provides a concise and thread-safe way to implement singleton. Next question can be, how do you ensure thread safety in a singleton implementation? Thread safety in single implementation can be ensured by using synchronized mechanisms such as locking, synchronized block, or leveraging Java's concurrent utilities like atomic reference and atomic integer. These mechanisms prevent multiple threads from creating separate instances simultaneously and ensure that singleton instance is correctly shared across threads. Next question can be, what are the drawbacks or potential pitfalls of using singleton pattern? Drawbacks of singleton pattern include introducing global state, which can lead to tight coupling and decreasing testability. Additionally, singleton instances are often difficult to extend or mock for testing purpose. Overuse of singleton can also lead to performance issues due to excessive synchronization or eager initialization. Interviewer can also ask a real-world scenario. One example of using singleton pattern is a logging system, where you want a single logger instance shared across the entire application. This ensures consistent logging behavior and prevents multiple logger instances from conflicting or causing excessive resource consumption. In the final segment, there is a quiz where you are tasked with pairing questions on the left with their corresponding answers on the right. Take a shot at it to access your comprehension. Your participation is appreciated. Thank you.